Same thing, they give us a different function though. They want 3x plus 1 all over the absolute value of x plus 2. Right? And so we want to look at the limit of this, and I'm just going to write it down, f of x as x approaches positive infinity and negative infinity. So when your textbook says if there's a limit as it approaches positive infinity and negative infinity, then it may have a horizontal asymptote, is really what the textbook should say. So if I could take a function and look at the behavior as it approaches infinity and I get a constant number, then there's a pretty good probability that there's a horizontal asymptote at that number. But as we saw in our last case, that isn't always true. So this is like a test. Think of it as like a test, a horizontal asymptote test. Okay? So what do I want to do? I want to graph this. This is going to be an interesting function. I think the domain should be all reals because I can't think of anything that would restrict the domain because we're taking the absolute value of x. So x will always be a positive value. So I'll never have like a negative 2 plus 2. So I'll never get 0 in the denominator is what I'm trying to say. Okay, looking good so far. Okay, yeah, that makes sense. Three and negative 3, right? Oh yeah, that makes perfect sense. So how does Mr. Adams know that it's 3 and negative 3?
You can look right there and see it.
Well, we talked about this before. You want to think, yeah, I could look at it and see it, but how do I know the exact numbers, right? It's the leading coefficients. So as we approach infinity and negative infinity, really what I'm looking at is 3x over, what's the possibility for x? Well, it could be negative x or 3x over positive x, right? So as I look at the behaviors of that, in other words, if I plug in infinity and I multiply it by 3, I get 3 times infinity. Does it really matter if I add the 1? No, it's insignificant, right? And same thing here. If I get the absolute value of infinity, does it really matter if I add 2 to infinity? No. So really, this is what we're looking at, right? How does that behave? Well, the absolute value means I could have a positive or a negative x. This is a positive 1x or a negative 1x. Well, if I plug the same thing up here and the same thing in here, in other words, these x's cancel because they're the same degree. Because they're the same degree, my limit should always approach either 3 or negative 3. I can verify this in my table of values if I hit second graph, right? As I approach infinity, negative infinity, that will get smaller and smaller and smaller and smaller and smaller and smaller and smaller. Wait a minute, what's my y value approaching? Oh, you know what, I gotta get out of here, I gotta change this. Let's change it. Let's do like 1. We'll start at 0 and we'll have a table of 1, the increment. Alright, so now, okay, that's better. I would have been scrolling all day, right? So now as what does this look like it's approaching? Well, as I keep going in this direction, it gets pretty close to what? Negative 3, right? And if I go in the other direction? Positive 3, right? Man, that'll take a long time. So if you want to, you could use the table of values like this. I could even change my increments to like 100, right? So if I come down here and I do like, I don't know, let's do something crazy. Let's do like 78. And but I want to start at 0 though. Let's start at 0. All right, here we go. Ready? Table of values. Check this out. Well, bam. If I keep going, it gets closer and closer to 3, but it'll never actually get to 3. Right, and if I go in the other direction, it'll do the same thing towards negative 3. But we can see that from the graph. Okay, so what I want to do then is I'm going to come in here, and so then the limit of f of x as x approaches infinity is positive 3, and the limit of f of x as approaches negative infinity is negative 3. Does that make sense to you guys? Okay, good.